Good day, teacher. For this linear algebra assessment presentation, we would like to share about the application of linear system in science and engineering. My group members including Mao Zixing, Zhu Zhixuan, and Joy Li Rouyi.
Hi, I'm Zixing. Let me introduce some basic concepts and related knowledges of linear systems. A linear system is a mathematical model used to describe relationships between variables in a way that satisfies the principle of linearity. And linear systems play a fundamental but key role in many fields. That's why we should learn and master it. There are the objectives of our video. Firstly, to understand the basics of linear systems. Then, explore the application of linear systems in nutrition science and highlight the practical implementations. After that, we'd like to emphasize the advantages of linear systems. Finally, discuss the future of linear systems in nutrition science. Then, let's see the characteristics of linear system. First, the additivity, also called the superposition principle, which means that if a system S is linear, then the output of the system for a sum of inputs is the sum of the outputs for each input individually, expressed in mathematical form as Sx1 plus x2 equals to Sx1 plus Sx2. Then, let's have a short talk about homogeneity, also named the scaling property. It means that if the input to the system is scaled by a constant, the output is scaled by the same constant, whose mathematical formulation is S alpha times x equals to alpha times Sx, and also time invariance is the characteristic of dynamic systems. If its behavior does not change over time, that is, a time shift in the input leads to an identical time shift in the output. In mathematics, if Sxt equals to Yt, then for any time shift t0, we have this. In simple terms, the system's response to an input is the same, regardless of when the input is applied. The system does not learn or change a lot. Then let's see the mathematical form of linear system. A linear system can be expressed in different mathematical forms depending on the context, such as linear system of equations, linear differential equations, state space representation, and transfer function. Among these, the linear system of equations Ax equals to b is the most commonly used. Let's look at a simple example. Consider the following system of the equations 2x plus 3y equals to 5 and 4x minus y equals to 6. It can be written as shown in the figure. Here, matrix A contains the coefficients of the variables x and y. Vector x represents the unknowns we want to solve for, and vector B contains the constants on the right-hand side of the equations.
Hi, I am Joy, and now let us proceed to the applications of linear system in science and engineering. Here is some of the examples of application in science and engineering, which is circuit analysis in electrical engineering, structural analysis in civil engineering, modeling pollution dispersion in environmental science, regression analysis in data science and machine learning, system stability and feedback control in control system, ecosystem interaction and stability in ecology, modeling electrical activity in neurons in neuroscience, and also diet optimization in nutrition science. And we are going to talk about how does the linear system works in nutrition science. In nutrition science, linear system act as a mathematical model to solve diet-related problems such as meal plans, nutrient intake, and also energy expenditure. It involves variables, which is quantities of food, and also equations, which is constraints of requirements, such as calorie intake. Linear systems in nutrition science are mostly used in meal planning, nutritional analysis, and also food security. For the meal planning, linear programming techniques help to design a meal that contains daily nutritional requirements. And for nutritional analysis, it is to determine the nutrient contributions of different food sources to a diet by solving the linear system's equations. And in food security, it is to create a cost-effective meal plan for low-income populations. This shows that how linear systems apply in nutrition science. The first step is we need to define the variables and set up the equations with the variables. Next, we need to express the equations into matrix equations, and finally, we need to solve the equations to get the final results. Let us look at one of the examples that using linear system to solve it. Calculate a nutritional diet plan for someone who needs to consume 2,500 calories per day with specific requirements for carbohydrates, fats, and proteins by using matrix form. And this is the nutritional target for the person. He needs carbohydrate for 50% of calories, fats for 30% of calories, and also proteins for 20% of calories. As we know, this is the macronutrient conversions. For carbohydrates, 1 gram is equal to 4 kilocalories. For fats, 1 gram is equal to 9 kilocalories, and 1 gram of protein is equal to 4 kilocalories. After we get all of the information, the first step is to define the variables. So, let x1 be the grams of rice, which is high in carbohydrate. Let x2 be the grams of avocado, which is high in fats. And let x3 be the grams of eggs, which is high in proteins. After we define all of the variables, the step 2 is to set up the equations. This table shows the amount of nutrients contained in the food and also daily nutritional requirements. And for daily nutritional requirements, it is calculated from total calories divided by macronutrient conversions and multiplied by the percentage of calories of nutrients. So from the table, we can set up these 3 equations for later use. And now we come to step 3. In step 3, we need to express the equations just now into the matrix equation, which is AX equals to B, where A is a 3 times 3 matrices, and X is X1, X2, X3, and for the B is the daily nutritional requirements respectively. And the last step is to find the X1, X2, X3 by row reduction. So, we need to solve the matrix equation AX equals to B into row-reduced echelon form to get X1, X2, X3 respectively. And this is the solution steps that we have made. Thus, by row-reducing the matrix into RREF, we get that X1 is equal to 10.83, X2 is 0.62, and X3 is 7.02. Therefore, this is our final result. So, the nutritional diet plan for someone who needs to consume 2,500 calories per day with 50% calories of carbohydrates, 30% calories of fats, and 20% calories of proteins is 10.83 gram of rice, 0.62 gram of avocado, and 7.02 gram of eggs. That's all for my part. Thank you for listening.
Hi, I'm Zhu Zhixuan. In discussion on the application of linear algebra in the field of nutrition and diet, we can understand the numerous advantages brought by linear system and thus look forward to its future development potential in this field. Firstly, linear system has demonstrated remarkable efficiency in practical application. By quickly solving problems, they can significantly reduce the time consumed in the train and error process, which is undoubtedly crucial for scenarios where a large amount of data and complex relationships need to be dealt with in the design process of nutrition and diet plans. Besides, cost effectiveness, scalability, and simplification are also highlights of linear system. By setting the requirement of various nutrients as the objective function and the nutrient content and cost of food as constraints, a linear programming model can be constructed to accurately optimize dietary combination plans. This method helps us achieve goals such as cost control and maximum resource utilization efficiency while meeting the nutrition needs of the human body. The application of linear systems in the field of nutrition and diet has achieved remarkable results and has brought development prospects in the future. We have reason to believe that linear algebra will continue to make positive contribution to improving people's healthy life.